learned about weighted averages and how to use those to find the average atomic mass, I want to do an example. In nature, carbon has 3 isotopes: carbon-12, carbon-13, carbon-14. The vast majority is carbon-12, 98.93%. Most of the rest is carbon-13, 1.07%. You may notice this already adds up to 100. That's because carbon-14 is only found in trace amounts. In fact, it's so little we really won't need that in order to find our average atomic mass. Now, we talked about last time we could get a good approximation of this by saying the mass of carbon-12 is 12 and the mass of carbon-13 is 13. But I did mention to you the idea of mass defect, and if we want to get the exact value, we really need the individual masses of the isotopes. And while it's really close to 13, it's not exactly 13. It's 13.0034. For reasons we'll talk about later, the mass of carbon-12 is exactly 12. It is that way by definition. Okay, so how are we going to find the average atomic mass? Well, we take the mass of the individual isotope, 12. It's really not necessary to write out these zeros, but I'll do so. And we multiply it by its natural atomic abundance, which is 98%. We change that to a decimal, 98.93%, 0.9893. So we just divided that by 100, move the decimal over twice. Then we are going to add the mass of the next isotope, which is 13.0034, and we're going to multiply it by its natural abundance, 1.07%, which we can write as a decimal as 0.0107. We're not going to include the carbon-14 in our calculation because it occurs in such small amounts that it doesn't really affect the mass. So we're just going to do these two values, and if we work those out and add that up, we get 12.0107364. Now, I have it rounded. I have not followed significant figure rules. If I did follow my significant figure rules, this has 4 significant figures, this has 3 significant figures, these have more. If I rounded this off to 3 significant figures, I would be rounding it off to 12.0. Okay? I do want to show you, though, without rounding off, our calculation agrees with what you would find on your periodic table because I've used actual values. 12.0107, if we rounded that off to this place, we get 12.011. That's what you find on your periodic table. Now, just wanted to give you an example of how to do that. I want to re-emphasize, if you are finding the average atomic mass, take the mass of each naturally occurring isotope and multiply it by its percent abundance, written as a decimal. Then add up those values, and that will give you the average atomic mass.